Just a moment, no? Okay. So we are going to start polynomials. Here, the first concept from this chapter polynomial is here we will be discussing about polynomials. Just a moment. Polynomials in one variable. Okay, so here we will be having expression. Now we can write that expression in the form of polynomial. Let's say px is equals to it can be x square plus 2x plus 3, this type of expression. Now we will represent it in the form of polynomial. Now the first concept here is the degree of the polynomial. How we will decide what exactly is the degree of the polynomial. So if the polynomial is given as a x to the power 5 minus x to the power 4 plus 3, anyone from here, can you tell me what is the degree of this polynomial? Or if we are having 2 minus y square minus y cube plus 2y to the power 8, from here, anyone, can you tell me what is the degree of the polynomial for the first one, for the second one?
8.
What's the meaning of degree of the polynomial?
Highest exponent.
Uh, I don't know why I'm getting the voice like it's very low. Let me check.
Can you hear me now?
Yeah, it is
Um,
audible.
Highest exponent.
Uh, you said 5,
For the first one, 5.
and for the second one,
8.
8, right? So the highest power of the variable, that is called the degree of the polynomial. And yes, here for the first one, the degree of the polynomial is 5. And for the second one, degree of this polynomial, this is 8. Okay. Now here we are having one concept, that is, yeah. So there is a table which says that when the degree is 0, name of the polynomial, we must, like, you must know the name of the polynomials. This type of question you will get it in the like format of fill in the blanks or maybe MCQ questions. So when the degree of the polynomial is 0, it's called constant polynomial. Okay. When the degree is 1, it's called linear polynomial. When the degree is 0, it's called constant polynomial. And can anyone say what will be the example for the degree 0 or constant polynomial? Any example? When the degree is 2, it's called quadratic polynomial. When the degree is 3, it's called cubic polynomial. and when the degree is 4 is called quartic polynomial. This much only you need to know. And the remaining one, 5 6 7 degree 5 polynomial, degree 6 polynomial, that way only we can just take that. Now what can be the example for constant polynomial? So basically it's any constant number. We can say the example for constant polynomial can be only 2 or maybe only 3 or maybe only 24, where the power of the highest power, if I am having only 2, then I can say the highest power of x over here is 0. That's why it's called that's why the degree of this polynomial is 0, and it's called constant polynomial. If we are having uh, any number, let's say 25, then we can say it's a constant polynomial. Here the degree of this polynomial, degree is 0. Okay, if you know the property of exponent, any term having power 0 is nothing but just 1. Okay, that's why beside 25 nothing is there, and I can write 25x to the power 0. Highest power of x over here is 0. Now linear polynomial, here the highest power of x will be 1, and the example of that can be 25x, or maybe 3x, or maybe 5x. Okay, or 5x plus 2. Okay, 3x plus 5. This type of polynomial is called linear polynomial, where the highest power of x is 1. Quadratic polynomial, the highest power of x is 2 over there. Cubic and quartic. Okay, now the next concept over here is zero of the polynomial. The first exercise completely, here the question I can see is from the concept of degree of the polynomial. What is the coefficient of x squares? Okay, so if we are having pi by 2 x square plus x, here can you tell me what is the coefficient of x square? Anyone? Coefficient of x square over here is Rumaisha. What is the coefficient of x square over here? Arya, are you there?
Yes,
5 by
ma'am.
2.
Yes, pi by 2 is the coefficient of x square. So this way only we will be finding the coefficient. Coefficient means whatever is multiplied with x square. Any constant, any number, or if nothing is there, here the coefficient of x is in front of x, whatever is there, or whatever number is multiplied with x, that is called the coefficient multiplier or coefficient of x. And here coefficient of x, if the question is what is the coefficient of x, that will be 1, because in front of x nothing is there, so 1 is multiplied with x. Coefficient of x square is pi by 2. Okay, now the next question is classify the following linear, quadratic and cubic polynomial. You will be able to do. We just have to classify. Is it linear polynomial? Is it cubic polynomial? Is it quadratic polynomial, or what? So that's why I have, first thing first, I have written the table how we will classify. So if the polynomial is given as a y plus y square plus 4, can you tell me whether it is linear or quadratic or cubic or quartic?
Linear.
It's linear. Yes, everybody is agreeing with her. It's linear polynomial. Here highest power of y is 2. If the degree of the polynomial is 2, the name of that polynomial is quadratic polynomial.
Oh,
Can
sorry.
you see the degree of the polynomial is 2 over here? So we can say it's the quadratic polynomial. Now zeros of the polynomial. So the next concept is zero of the polynomial. Zeros of the polynomial. So 0 of the polynomial means what we will substitute as a value of the variable so that the whole expression will become 0. So if we are having a polynomial px is equals to 2x plus 3, what will be substituted at the place of x so that this px will completely be 0? That is called the 0 of the polynomial. Okay, x such a value of x which will make the whole expression 0, the whole polynomial 0. So to calculate the 0 of the polynomial, just a moment. Yeah, so if we will take let's say, suppose we are having, let me take a very basic example. Let's say a polynomial qx is there, and this polynomial qx is equals to, let's say, x plus 2, and we have to find the 0 of this polynomial. Now such a value of x which will make the whole expression, whole polynomial 0. Okay, that is called the 0 of this polynomial. So here you can identify clearly that when you will take x as a minus 2, then and only then qx completely will become 0. So x, the value of x is, that is minus 2, is called the 0 of this polynomial. 0 means such a value of x, x ka wo value which will make the whole polynomial 0. How we will find that? We will not, here it was very simple, just by guessing that okay, when we will substitute x value as a negative 2, we will be getting the polynomial qx as a 0. So x equals to minus 2 is called the 0 of this polynomial. Okay, it was simple over here to just guess or identify by looking at the polynomial. But when we are having polynomial like this, maybe px is equals to 2x plus 3, in such scenario, 0 of the polynomial means you just take px as a 0 and solve this equation 2x plus 3. Take px as a 0 and solve this equation 2x plus 3. You will be getting x value as a minus 3 by 2. And this x value is called the 0 of this polynomial. The meaning of 0 is such a value of x which will make the polynomial 0. Okay. Now the next concept related to this, let me check few questions. Yeah, finding 0 of the polynomial in each case. So suppose we are having a polynomial px is equals to ax, and we have to find the 0 of this polynomial. How we find the 0 of the polynomial? Such a value of x which will make the polynomial 0. And we will not just look at the polynomial and we will try to identify what can be the value of x, what can be the value of x. We will just put px value as a 0 and we will solve the equation. That way we will get the 0 of the polynomial. Okay, so if we will solve it, ax is equals to 0. So this signifies that either a is 0 or x is 0. Okay, here in the question one more condition is given, that a is not 0. Okay, so if a is not 0, which is given in the question itself, this is invalid. X is 0, that is the 0 of the polynomial. So 0 of the polynomial, whenever we have to find, again I am repeating, px, qx, rx, fx, whatever is written on the left hand side, or maybe like this polynomial, like the representation px, qx, rx, just write 0 at the place of that and solve the equation. By solving the equation, you will get a value of x, and that is called the 0 of the polynomial. Now, what is the meaning of the 0 of the polynomial? Such a value of x which will make the whole, which will make the polynomial 0. Okay. Now, if we are having a polynomial px is equals to cx plus d, please don't get worried if it is asked in the question, find the 0 of this polynomial. Then you must be thinking, okay, I have said take px as a 0 and solve the equation. Now, how can we solve this type of equation, such a weird equation we are having? No worries, the way you solve a normal equation, same way solve it. So you will be getting cx plus d is equals to 0. That means cx is equals to minus d, right? This way only we solve the equation when we are having a real number. Like when we are having 2x plus 3 is equals to 0, what we were doing, 2x is equals to minus 3. Similarly, d we have shifted to other side. It was positive over here, it became negative on the other side. Now x value, how we used to find? If c is multiplied with x, then we can write it as a minus d by c. What is the value of x? The value of x is this one, which is called the 0 of the polynomial. Okay? Is it clear to everyone?
Yes, ma'am.
This way we will be finding the 0 of the polynomial. Any polynomial is given. If numbers are not there, if constants are there, or c, d, e, f, this type of constant are used, then also we need to solve it just like a normal equation. By assuming that this c is a number, this d is a number, x is a variable. Okay. Now another concept over here is, suppose we are having a polynomial px is equals to x minus 1, x plus 1, and we have to find p0, we have to find p of 1, we have to find p of 2. So if we have to find p0, then at the place of x we will be substituting 0. We will be substituting 0 in the original polynomial. So x ke place pe 0, we will substitute 0 minus 1, 0 plus 1, and that will give our answer for p0. Now what is p1? So at the place of x I am going to substitute 1. So here x I'll be writing 1 minus 1. Here x I'll be writing 1 plus 1, and that will give us the result. P2 at the place of x in the original polynomial we will be substituting 2. P of chocolate will be at the place of original polynomial, we will be substituting chocolate. So whatever P we have to find. If we have to find, let's say Px is given as a same polynomial, x minus 1, x plus 1. If you have to find P of k, then you will be substituting k at the place over here. Here at the place of x, k minus 1. Here at the place of x, k plus 1. Okay. If you have to find p of a plus b, then as I said, whatever you have to find, x has to be a plus b. Okay, forget about this one. This was part 1 question, like one of the question, and this is part 2 question. Okay, if we have to find p of a plus b, then at the place of x we will be writing a plus b over here, minus 1 I am copy pasting. At the place of x I'll be writing a plus b plus 1. This is our polynomial, like this is the required polynomial at x equals to a plus b. Is it clear to everyone?
Yes, ma'am.
If px is given as a the same polynomial x minus 1, x plus 1, and if we have to find p of a plus b plus c, then no worries, at the place of x we will be substituting a plus b plus c minus 1, a plus b plus c plus 1. We cannot solve this one. Yeah, we can simplify maybe by using formula or something, but we cannot solve it. Here's addition, subtraction we cannot do. So we can leave our answer like this one. This is our answer. Okay. So from here you must have understood that whatever we have to find at the place of x, we will just put it over there and we will get our polynomial at the given value. Okay, this if you will be able to do this type of question, and you will if you are also able, like if you are also comfortable with the zero of the polynomial, that type of question, then you are done with exercise 2.2. Okay, I am going to move ahead and discussing the next part. Let me check what is that. First exercise, degree of the polynomial, coefficient of the polynomial. Second exercise, zero of the polynomial, and also finding the polynomial at a certain point. Now the third exercise. Okay, so the next one is remainder theorem. Yeah. Yeah, so basically remainder theorem says there is a long division method which we will be discussing just after a while. Let's discuss that and then we will come to remainder theorem. Yeah, long division method says if we have to divide, you know how to divide 6 divided by 2. This type of division you have learned in the lower classes only, maybe in class 1 or class 2. You have learned how to divide this one, or maybe how to divide this one, or maybe how to divide this one. This type of division you have already learned in like lower classes. Now here we will be learning, like we will be discussing how to divide polynomials. So if we are having, let's say, 6x square plus 7x minus 20, and if we have to divide this expression, this polynomial, we have to divide by 2x plus 5, then how we will be doing the division? Let's see. So I am going to take 2x plus 5 as it is, then 6x square plus 7x minus 20. This is how we will just write it, and then we will do the division. While doing the division, if you already know the process, well and good. Here in briefly, like a brief explanation I am giving. So here we are having 2x, here we are having 6x square. We will not focus on the remaining term. We will only focus on this 2x and 6x square. 2x and 6x square. Now, what should be multiplied with 2x so that we will get 6x square? 2x में क्या multiply करे कि हमें 6x square मिल जाए? Okay, so obviously if you will think like that, what should be multiplied with 2x, what should be multiplied with 2x so that we will get 6x square? You will be able to figure it out. Okay, 1x is required so that it will be x square, and 6x square is there, so 3x must be multiplied. So 2x में 3x अगर multiply करेंगे तो हमें 6x square मिल जाएगा. If you will think like that, you will be able to figure it out. So here we will take 3x. 3x should be multiplied with 2x so that we will get 6x square. Let's write it. So we will be getting 6x square over here. Now this 3x will also be get multiplied with this 5. We don't want to multiply 3x with 5, but we don't have only 2x, we have 2x plus 5. So whatever we are taking as a quotient, we have to multiply that with each and every term. So we have to multiply this 3x with this 5 also. Okay, so it will become 15x. And here we will do subtraction the way we do in normal division, and then the first, this two term cancel out each other, and the next term here we have negative 15x plus 7x, it will be 8x minus 20. Is it clear to each and everyone over here? Let me know. Is it clear?
Yes, ma'am. Yes, ma'am.
Okay, let's move ahead. So we are having 8x minus 20. Now we will go ahead and we will be doing the same thing. Now we will focus on this 2x again and this 8x. What should be multiplied with 2x so that we will get 8x? So we will figure it out. Okay, 2x in 2x, if we will multiply 4 plus 4, just be particular with the sign whether it is plus 4 or minus 4. So if we will multiply plus 4, it will make 2x into 4 will be 8x. So 8x and plus 20, if you will do the subtraction, yeah, it will be minus 40. Here, if it would be plus 20, then the remainder will be 0. Let me check whether it was plus 20 over there. Okay, one thing we are missing over here. Yes, it was negative 20 over there only. One thing we are missing over here, that minus 15. This minus 15 plus 7 will be minus 8, right? So our quotient over here will not be plus 4. It will be minus 4. Okay, because we need minus 8. If you will focus on the yellow part, you can see minus 8x we need. This minus 8x we need. Okay, because we have done the subtraction. We have done minus 15x plus 7x. That is negative 8x. That will be here. Okay, so here it will be minus 4. Then only we will get minus 8. Okay, and here it will be minus 20. Now you can see if we will do the subtraction, each and every term will cancel out each other and the remainder will be 0.
Ma'am, how
Our
did minus
quotient or
20
the
come
answer
there?
is x minus 4. Yeah,
How did minus 20 come there?
minus 20. It was minus 20 over here. I have copy pasted over here. And then this minus 4 I have taken. Minus 4 multiplied with 5. Minus 4 into 5 became minus 20. Right?
Oh, okay.
So here we are having the upper part. Here we are having the upper one as a minus 8x minus 20. In the lower part also we are getting minus 8x minus 20. Now if you will do the subtraction, this will become, this minus 8x will become plus and this minus 20 will be plus. Eventually both will cancel out each other. Right? Are you getting it, Arya?
Yes, ma'am.
So we got the remainder as a 0. Our answer is 3x minus 4. Okay. This is how we will be doing the long division method. Now long division method, if you already know, like perfectly fine. If you don't know, I believe you have understood it from here. One type of long division method is there. One type of question is there where a student mostly get confused. That is, suppose you are having 2x plus 5 and you have to do the division of 6x cube plus 7x minus 2. Okay, if this type of division you have to do, forget about the previous part. If this type of division you are doing, you must be thinking it's exactly like the previous one, but no, it's not. Here I have changed the power. This power of x I have changed. So 2x and 6x cube. This one and this one we will focus. What should be multiplied with 2x so that we will be getting 6x cube. So 2x multiplied with 3x square, then only we will be getting 6x cube. So here we will be having 3x square. That will give us 6x cube. Now if you will multiply this 3x square with this plus 5, because you have to multiply it with each and every term. You were focusing on the first term, that is okay, but eventually you have to multiply it with each and every term. So 3x square will also get multiplied with 5, that means 15x square. Now you must be thinking here, if we will be having 15x square, how we will be doing the calculation of this 2? Anyone? Can you tell me how we will be doing the calculation of this 2? Previously it was 7x, 15x. Calculation was possible. But now is it possible, the calculation 7x, 15x square? Is it possible?
No.
No. In such scenario, subtraction sign, this sign will also change. We will be copy pasting. If calculation is not possible, we will be writing minus 15x square plus 7x. We will be writing it as a next step. And then again we will try to divide it. Since this question I have taken by myself, here you must be taking a number which will be divisible by 2. Instead of 15, you will be getting, let's say, uh, maybe this 2x plus maybe 6 will be there. Okay, since I have written this question by myself, that's why we are getting such number, that is 15. Now if you will think what should be multiplied with 2 to get 15, that is not possible. Okay, so this type of question whenever you are having, it's okay. Here if we are having 6, it will be 18. So 18x square plus 7x. This type of construction you will be getting. I just want to show you with the help of this example that whenever you are getting x square and x, a term one below other, and if you are unable to just figure it out that how we will be doing the calculation now, no worries, just write the x square term also and x term also as it is, and again just continue the same process. That's why that's what my motto is, to explain with the help of this example, that sometime you will be getting this type of construction where you will not be able to do the calculation, the addition, the subtraction of two term. You will not be able to do the calculation because there the variable will be different. Like one will be having x, another will be x square, or maybe one will be having x square, another will be x cube. So you will not be able to add them together, you will not be able to subtract them together. Then what you are going to do in such scenario, just copy it again, the below one and the above one as it is with its sign, and then again continue the same process of division. Am I making sense to everybody over?
Yes, ma'am.
Okay, so this is what I wanted to explain over here. Now long division method, if this is clear to you, let's move to the next concept, that is remainder theory. Now, remainder theorem says that rather than doing the long division method and then figuring it out what will be the remainder, there is one easier method. What that method says that uh, we can find the remainder. Let's say, suppose, let me take one example. Let's say we are having when x square minus 3x plus 2 is divided by x minus 3, then what will be the remainder? So the remainder, we can do the long division method. Let's do it. X minus 3, and here we want to divide x square minus 3x plus 2. Let's see what will be the remainder. So x is there. How we do the long division method? The previous one, x square. What should be multiplied with x so that we will get x square? x में क्या multiply करें कि हमें x square मिल जाए? So x में x multiply करेंगे, positive x, then only we will be getting x square. So here we are getting x square. Now this x will also get multiplied with this minus 3, so we will be getting minus 3x over here. Now subtraction sign, this 2 and this 2 will cancel out each other. We are having 2 over here. This 2, I am going to write it down. Now here x is there, here 2 is there. So we can identify now no division is like the next process. It's not possible. Here only we have to stop our division because here the remainder one doesn't contain any x. It must contain x or higher power than x. Then only we will be able to continue the division. Now we cannot continue the division. Here only we have to stop. So we can see the remainder is 2 over here. Remainder theorem says rather than doing this long division method, which was quite short over here, it can be long. Rather than doing this division method, directly we will get the remainder. How? So there is one magical formula. There is one magical process. What is that magical process? That process is if you have to divide x square minus 3x plus 2 by x minus 3, then first find the zero of this polynomial. This is a polynomial, zero of this polynomial. How we find the zero of this polynomial? Just by writing x minus 3 is equals to 0 and x value is 3. X value 3 is called the zero of the polynomial. Why? Because it is making the whole expression as a zero. जीरो ऑफ द पॉलिनोमियल का मतलब ये नहीं होता है कि x का वैल्यू जीरो होगा. जीरो ऑफ द पॉलिनोमियल मीन्स सच अ वैल्यू ऑफ x, x का वो वैल्यू विच विल मेक द पॉलिनोमियल जीरो. So here x का value 3 is making the whole expression 0, and that is x equals to 3 is called the zero of the polynomial. Now first thing first, we will be finding the zero of the polynomial, that is 3. We will substitute it in the given expression in the given polynomial. So if we will substitute it over here, 3 square minus 3 into 3 plus 2. So 3 square is 9 minus 6 plus 2. So 9 minus 6, that is 3. Just a moment. Am I doing any mistake? Okay, yeah. Here. This is not 6. This is 9. Who will tell me? This will be 9, right? Yes
Yes.
or no? So 9 minus 9. 3 into 3 will be 9, right? Not 6.
Yes, ma'am.
9 minus 9 is 0. 0 plus 2 is 2. So remainder we got as a 2. By remainder theorem, we got the remainder as a 2 without doing this long division method, which we have done on the upper side. So long division method, whatever remainder we will be getting after doing the whole thing, the whole process of division, that directly we will be getting by applying the remainder theorem, which says that if you are going to divide, let me take one more example and let me explain, just take the whole scenario again. Find the remainder when x cube minus ax square plus 6x minus a is divided by x minus a. We have to find the remainder when the given expression is divided by x minus a. Now here we know x minus a, this is the divisor, and we have to divide x cube minus ax square plus 6x minus a. Okay, this is called the dividend. So we have to divide it, but not by long division method. we will be applying the remainder theorem, and directly we will be getting the remainder. So what exactly the remainder theorem says? That find the zero of the divisor. Okay, first find the zero of the divisor. So zero of this divisor will be x equals to a. This x value is called the zero of this divisor. Now substitute this 0 in the given polynomial or in the dividend. So we will be substituting x value as a, it will be a cube, minus x value as a, it will be a times a square, plus 6 into a minus a, we will be getting a cube over here, a cube over here, plus 6a minus a, 6a minus a will be 5a, and that is the remainder. How we got the remainder? We have found the zero of the divisor, and that zero, that x value, we have substituted in our dividend, and that way we ended up getting the remainder directly. Is it clear?
Yes, ma'am.
Let's move ahead. Now there is a factor theorem, and then identities are there. Identities you will be able to do by yourself. Factor theorem I am explaining over here. Let me take few examples from here. Okay, so the example can be, or the question can be, examine whether x plus 2 is a factor of x cubed plus 3x square plus 5x plus 6. Okay, let's keep it this much. So we have to examine whether x plus 2 is a factor of this one or not. For applying the factor theorem, what we need to understand, if we are having a number, let's say 6, how to do the factorization of this number? We can do the factorization like 2 into 3. So 2 and 3 are the factors of 6, I can say. Now if you will multiply 6 by 2, you will get the remainder as a 0. If you will divide 6 by 3, you will get the remainder as a 0. So factor of 6 are 2 and 3. 2 and 3 are the factor of 6, and if you will divide 6 by any of the factor, either by 2 or by 3, you will get the remainder as a 0. So from here you can understand, if you are getting remainder 0, then you can say the given divisor is the factor. If you are getting remainder not 0, then you can say it's not the factor. Okay, if we are having 6 over here, and if we will divide it by 5, if you will divide, 5 1 times 5, the remainder is 1, it's not 0. So 5 is not the factor. If you will divide by factor, the remainder automatically will come out as a 0. So here we have to check that x plus 2 is a factor or not. So we can say if the remainder will come out as 0, then we can say it's a factor. If the remainder will not be 0, we can say it's not a factor. Are you getting it?
Yes, ma'am.
So if the remainder will be 0, it's a factor. If the remainder will not be 0, it's not a factor. How to check the remainder? By long division method? No, we will not waste our time. We will apply remainder theorem. Remainder theorem says this is the divisor, find the 0 of it. So 0 means x plus 2 is equals to 0, which will give x value as a minus 2. This x value minus 2 we will be substituting in our dividend. Let's substitute minus 2 cube plus 3 minus 2 square plus 5 minus 2 plus 6. Here we'll be having 8. Here 4
minus 8.
times 12 minus 8. Yes. Minus 10 plus 6. Just keep on observing. Okay. This type of calculation error, if anywhere happening, let me know. I need to correct it, or I need to write this one as a that way. Okay. Minus 8 minus 10, it will be minus 18 over here, plus 12 plus 6 plus 18. So remainder is coming out as a 0. So can we say x plus 2 is a factor? Yes, it's a factor. Can we say?
Yes.
Yes, we can say. Since the remainder is 0. If the remainder will not come out as a 0, we can say it's not a factor. Remainder is 0, it's a factor. Remainder not 0, it's not a factor. Next exercise is totally related to this concept, where you have to check whether it's a factor, whether it's a not a factor. And then we are having identities. Okay, let me check. Algebraic identities: x plus y whole square, x minus y whole square, x square minus y square.